Okay, I'm still super busy, but I just want to share two cool papers. Science papers are intimidating, huh? This paper, Geometry of Abstract Learned Knowledge in the Hippocampus, is 20 pages with dense looking text. Most of the words here I need to squint at and Google. I know what a mouse is, sure, but how does a mouse express GCAMP6F exactly? But we don't have to give in to intimidation, Squidlings. The 20 pages of dense text has lots of pictures, and an abstract, a summary, relatively small in a slightly larger font. But still, the vocabulary here can be intimidating, so I'll try breaking the summary down into a more approachable summary. The hippocampus is this part of your brain shaped like a seahorse. A mouse's hippocampus lets it remember physical variables, like their position in a maze, or whether they found food there. The hippocampus can also encode some abstract, learned variables, but that's harder to study.
That ought to keep the little squirts happy.
Thankfully, this paper shows how the hippocampus integrates learned variables jointly alongside physical variables. In mice, it's always mice. These mice were put in virtual reality on little treadmills. Yes, really, if you want to track their neurons, it helps to keep these little mice still.
The mice take very naturally to it. That's something that gives us confidence that they are behaving normally, and we're interested in sort of having the animals do these sort of very kind of intelligent behaviors.
The mice walked through a virtual hallway with pillars on the left and right until the mice reached a fork. If the mouse turned in the direction which had more pillars, it got food. If the mouse turned in the other direction, it got nothing. Across 7 mice, the paper finds a consistent way their hippocampus's neural activity was creating a geometric representation of physical variables and related abstract variables the mice had learned. Apparently, knowledge looks like a low-dimensional manifold encoding of our high-dimensional environment. What's a manifold? Let's check Wikipedia. In mathematics, a manifold is a topological space which locally resembles Euclidean space near each point. Let's check simple English Wikipedia. A manifold is a concept from mathematics. There we go, that's more my speed. Easy Wikipedia explains a manifold is what you get when you make a low-dimensional thingy, which is approximating a higher dimensional thingy, like the 2-dimensional map of the 3D planet Earth, or a simple version of Wikipedia, or the short abstract of a long, complicated science paper, or a YouTube video where a squid tries to describe that abstract. The reason I wanted to talk about this paper is because it's really cool. But also, the idea of a manifold took me back to another paper, which is really, really cool. Driven by compression progress, a simple principle explains essential aspects of subjective beauty, novelty, surprise, interestingness, attention, curiosity, creativity, art, science, music, jokes. Says that everything I just listed was created out of curiosity, the desire to create or discover data that is novel and surprising, meaning it allows compression progress because its regularity is not yet known. We want to compress ideas to make them simpler. Something can be beautiful and interesting if it reveals a new way to compress ideas more. Consciousness itself, self-awareness, is a byproduct of compression, which will only make manifolds more and more sophisticated as our curiosity is satisfied. We are complicated mice in a complicated maze. I make funny, low-dimensional YouTube videos for it. Bye-bye. By the way, I've got a Patreon at patreon.com/thinkster. I want to thank all these squidlings and elder squids. Thanks.